In this video, we're going to talk about the discounted cash flow valuation. I want to call it a process. It's a tool or a technique that we use to identify the time value of money and how that impacts decision making. So to make good investment decisions, we obviously need to understand something about cash flow. We need to know when the cash flow occurs, but we also need to understand something about the riskiness of cash flow. And incorporating that riskiness along with identifying the time of cash, we can create something or do something called time value of money approximations. We can adjust the values of cash flows to time. We can do that with formulas, financial calculators, with spreadsheets. But essentially, we have a series of cash flows that we can forecast, obviously through projects, through securities, etc., and utilize this time element, this type of timeline, if you will, to identify value. So what are the variables? PV is the present value or the beginning amount. R is the interest rate. It also is I divided by Y, which is interest rate per year. So this is our nominal interest rate. FV is future value. N is years. A is annuity. An annuity is a series of equal cash flows for a certain period of time. And of course, we can have a present value of an annuity or a future value of an annuity. Sometimes we also refer to this as payment, right? Instead of A, it could be payment, PMT. M is the periods per year. This incorporates our time value of money and the compounding of interest. So let's start with future value. As you see, the formula is not terribly difficult, but it certainly is a little time consuming. If you're using Excel, there is a formula. It's the rate, number of periods. Now, what you have to remember is number of periods here reflects the actual times you calculate interest. So if you have M that is greater than 1, then the interest rate has to be divided by M, as it is in the formula here, and the time has to be multiplied by M, which is here. And of course, then we have payment, present value, and type. Type refers to when the actual cash flow occurs. The default is 0, which is today. So for in this case, it's an ordinary annuity, which means the cash flow occurs at the end of the time frame. So here is an example. We invest $1,000 in these time value of money tables, and using this tool, even financial calculators, you have to remember that the cash flows have to have a sign. Investing means money is going out of your pocket, so negative $1,000 would be the investment. 7% interest, 5 is years, compounding frequency is 1. This isn't an ordinary annuity, it's a lump sum question, but we do have to remember that typically this sign is always, or this cell will always be 0. It implies cash flows occur at the end of the period. And of course, in this case, when you solve for future value, it is $1,402.55. Now, if you do it algebraically, of course, you're going to get some rounding error because you're not going out as many places. So the actual answer, 1402.55, is the correct answer. What about present value? Again, you see we have the same setup of formula for Excel, except we start with present value. And again, here is our ultimate calculation. You take the future value and divide it by this denominator that looks an awful lot like the denominator, the multiplier we had in the future value calculation. So again, we're going to get $2,000. You're going to receive $2,000 in 5 years, and you can earn 10% on your money. What is this $2,000 worth in today's money? Well, solving for present value, we have negative $1,241 and some pennies. So the negative just implies that you would need to invest that in order to get $2,000 in the future. What about ordinary annuities or annuities in general? Again, we have the exact same formula, except now we have this payment in the middle that's where we'll have a number. The present value will not have a number unless it's a more complicated problem. But remember, the payment, since we're thinking about future value, you're going to invest to get to the future. This payment should go in as a negative number. As you can also see, the formula becomes increasingly more difficult as we add the different cash flows over time. So again, we have a cash flow. You can use the formula, certainly. Excel formula works great. And again, the type here needs to be 0. It tells us that the cash flows that you're receiving or the cash flows that you're investing occur at the end of the period. So here's a future value of an annuity example. We're going to invest $2,000 a year for 40 years at 12%. How much money would you have in this account if this indeed happened? And the answer, the answer is right here. The future value of an ordinary annuity, $1,534,182. Now, without getting into a whole explanation of compounding, etc., what would be the answer to this question if we made monthly payments instead of annual payments? Well, to do that, we need to change the compounding frequency. We need to change the M, the periods per year, to 12. But of course, we're not going to make $2,000 payments a month. You have to divide 2,000 by 12. So you change the payment to $166.67, making it negative. Change that compounding frequency, and the answer that you get is $1.96 and some change million. So making the exact same investment, but doing it on a monthly basis because of compounded frequency and interest earning interest would actually earn us roughly $430,000 odd more dollars. So the moral of the story is, if you are going to invest, you should probably try to do it on a monthly basis. To do annuity again, we have a slightly more complicated formula. But again, for the Excel thing, all we have to do is change the type from 0 to 1. And likewise, in our spreadsheet, if you change it from 0 to 1, you also would get the annuity due if you started today rather than at the end of the period. And again, it will make a substantial difference in the answer. The present value of an ordinary annuity, again, present value in the beginning, payment's going to be in here. but remember, we're going to probably be receiving this payment. So that would be positive. There'll be no future value here, but the type now has to be back to 0 because this is an ordinary annuity. So in this case, we're considering an investment, right? It's $35,000 in each year, and it's going to have a 4.79% in return. So what's the value of these payments? If we're going to get $35,000 a year, what's the value in today's money? So again, 4.79 is the interest. Time is 10. Compounding frequency, we said it's annual. Ordinary annuity, we're told it's an ordinary annuity. How do we know it's ordinary annuity? It says at the end of the year. 35,000 is the investment per year, so or the receipt per year. So we would receive the present value of an ordinary annuity is this $273,038.24. So that is the value of what this thing is worth. If you wanted to buy this investment, this is the most that you'd be willing to pay for it. It's what you think its value is. And indeed, we can actually do the exact same thing as we talked about earlier. We can do annuity due. Annuity due, again, for Excel, you change the type from 0 to 1. The rest of the numbers stay the same. And again, this will assume that whatever the cash flows are, the cash flows occur at the beginning of the time frame, at the beginning of the period. And you can see that the present value of an annuity due is a complicated formula to do by hand. So I'll talk to you in the next video when we talk about some more time value issues.